we will go into synchronous drive of control, synchronous motor drive. Synchronous motor drive control strategy. Ini kejap sorry. Sini. Oh, sini. Yes. The synchronous motor speed control method. Okay. Kita ada synchronous motor. The speed of the synchronous motor also can be controlled. Now kita nak learn how to control the speed of the synchronous motor and what are the methods. Yeah. In induction motor, you ada variable frequency and kita dah belajar. Sorry. Sekejap Alamak. Okay. So in induction motor, kita dah belajar the control strategy. How many types do you have? Actually you have 3 types. Okay, you ada VA tapi ini jarang diguna. Okay, you ada the second one is constant V over F. Okay, then the third one you ada variable frequency constant voltage control. And this V over F is below the base speed kan? Below base speed. Okay. And frequency be less than rated frequency, betul ke? And VT, the new VT will be equal to K VT rated. Betul macam ni? This one?
Betul.
Okay, for variable frequency, constant voltage, you akan ada the frequency, this one for above the rated speed. Okay, and your F now will be greater than F rated. VT new equal to VT rated. Betul macam tu. Okay, ingat lagi tak apa yang kita belajar untuk DC speed control strategy? Siapa masih ingat? How many types do you have? 1?
VA control.
Yes, VA control. This one for below the rated speed. The second one?
Flux control.
Yes, we have flux control. Okay, these are the control method for DC motor. Ini for the induction motor. Now we want to look at on the synchronous motor pula. Okay, kejap lagi kita buat yang ni. Okay, if you still remember, actually the synchronous motor is a 3-phase motor, but we assume it is a balanced motor for this topic or for this subject. We are assuming that this synchronous motor is a balanced motor and we only analyze per phase equivalent circuit. So the synchronous motor have the field winding, okay, where you have VF and IF, okay, on your rotor side, and you have armature winding where this armature winding are supplied from the 3-phase supply, okay, and this is the equation of the armature winding. EA angle there equal to V phase minus IA RA plus JXS. Okay, where V phase is the stator phase voltage, the armature phase current, all the phase value, armature winding resistance and synchronous reactance, and EA is your generated voltage. Masih ingat kan this formula? Okay. We already analyzed the per phase equivalent circuit previously. Okay, but this one for permanent synchronous motor, permanent magnetic synchronous motor, there will be no field winding in the equivalent circuit, but we didn't cover the permanent magnetic synchronous motor. Okay, so for the speed control of the synchronous motor, it is just the same as the induction motor. Okay, if given torque speed characteristic, the steady state speed can be changed by altering the torque speed curve of the motor. Macam previously kita ada induction motor. Ni the torque speed curve. Kita boleh alter the torque speed curve based on the method or the speed required. So we can shift to the left or we can shift to the right kan, sama ada left or right. Okay. For the torque speed characteristic of the synchronous motor, macam mana graph dia? You still remember? For the synchronous motor macam mana? Hello, graph dia macam mana? Straight line macam ni, ingat tak lagi? Okay, this is the torque speed. Characteristic of the synchronous motor. In this synchronous motor, Nm will equal to Ns. Okay, the speed of the motor will be equal to the synchronous speed of the motor. Macam ni. Induction motor, macam ni dia punya torque speed. This is for the synchronous motor. Semua kita dah belajar hari ni. And this is how you calculate the torque for the synchronous motor, 3V phase EA sin del, where EA is you're taking only the magnitude. And this is how you calculate your omega m. Okay? Ataupun nanti Nm macam biasalah. Yang formula yang kita guna sebelum ni. And there are also two methods to control the speed of the synchronous motor, which are the constant V over F control and the variable frequency with constant voltage control. Sama saja macam induction motor. Okay, this is how you can control your synchronous motor speed. Okay, both by varying the frequency. Kalau constant V over F, F is less, F new is less than F rated. If variable frequency, F new is greater than F rated. Ini semua saya dah tunjuk dalam video which I ask you to watch before the class. Okay, the theoretical explanation all in the videos. Nanti please go back and watch the video. Okay. Okay, for the first method, the synchronous motor speed control with constant V over F control. Okay, semua ni saya dah explain. Frequency F is reduced. Okay, and F is now is less than F rated. With stator voltage also reduced. Macam mana dia reduce ni? Okay. Vt new equal to kVt rated kan? Nanti we calculate lah for the phase voltage. So in this case, you want to maintain the V over F ratio. And this method is suitable for below rated speed where the pull out torque remain almost constant. Constant macam dengan induction motor juga. And at very low speed, the operation of starter voltage must be boost. Okay, nanti you tengok ni, the theory. Tapi ini the theoretical part, constant V over F, just the same as the induction motor. Okay. Okay, as you know, the torque speed characteristic of the synchronous motor semua dia straight line. Okay, this one straight line. This one at rated katakan at start number 1. Okay, at the new operating frequency F new, the new synchronous speed is calculated by using this formula. Okay, so katalah kita nak reduce the speed to number 2. Okay, so we have a new omega sekarang, omega 2. And this is new operation point lah of the speed. So now you shift the graph to the left, means you reduce the frequency F new is less now than F rated. Therefore, the speed also will be lower than the rated speed. So the voltage must be applied, calculated by this value, V phase new equal to K V phase rated. And also the reactance also will be, you will have a new value. Okay. And how to calculate your K equal to F new over F rated. Where for constant V over F control, the K must be between 0 to 1 because F new is less than the F rated. Boleh ke? It's just the same as the induction motor, but now the synchronous motor is a straight line, so dia akan shift straight line ni lah ke to your left, okay? Where Nm equal to Ns. So in this synchronous motor ada tak slip speed? Ada slip
Tak
speed?
ada, tak ada. Tak ada.
Tak ada. Your NSL tak ada, is zero. Tak ada pun equation for slip speed ni ya. Alright. Boleh faham? Okay, this is for constant V over F control of the synchronous motor. Formula dia lebih kurang sama je. Bukan lebih kurang, memang sama dengan your induction motor. Okay. Okay, the speed range also is very large. Okay. For the synchronous motor, daripada sini dia boleh ke sini. You can reduce the speed lah. Okay. Now, the second method is variable frequency with constant voltage control. Okay, sorry. Okay, this is suitable for the operation above the rated speed. Okay, this is omega rated. If you want to increase the operational speed of the motor, you must apply the variable frequency and constant voltage control. In this case, the frequency is increased. Kalau ke arah kanan, the frequency is increased. And now the new frequency is greater than the rated frequency. Alright. What about the V phase and terminal voltage? Tengok kat sini. The stator, terminal voltage and phase voltage is kept constant. Okay, just macam sama je dengan your induction motor. And now, the torque dia akan decrease slightly. So, the torque slightly akan decrease when you increase the speed. Okay, when you increase the speed, the frequency, omega pun increase, but the torque slightly reduce. Boleh ke? Boleh
Boleh.
Boleh, insyaAllah.
Okay. So, these are the formulas when you apply the variable frequency with constant voltage control. The first one is the new synchronous speed based on the new frequency. And the second one is the reactance, the new reactance. XS equal to KXS. Yang rated ataupun yang old punya. What about the voltage? Macam mana voltage? VT?
VT rated.
VT will equal to VT rated. Dia constant ya. Constant VT. Please jangan confuse ya. So, to calculate your K is equal to F new over F rated. And for this method, K is greater than 1 because frequency new now is higher. Okay, F new now is higher than F rated. Okay, boleh? So this is the summary of speed control method strategy for the synchronous motor. Okay, we have two methods. The first one for below the rated speed. Below the rated speed, you are using constant V over F control where frequencies is varied and frequency must be less than rated frequency. In this case, V new, V phase of VT new equal to K VT rated. And to maintain the V phase over F ratio. And dia akan operate below the rated speed je lah. Cannot more than the rated speed. Okay. The second one, variable frequency with constant voltage control where frequency varied. F is always greater than F rated. Where the voltage kept constant at voltage rated. But the torque slightly reduce when you increase the speed ataupun you increase the frequency, and this is for the operation above the rated speed. Alright. Okay, up to here, do you have any question? Ada soalan tak? Any question?
Tak ada dah.
Tak ada. So kalau tak ada soalan, kita buat satu menti question where you have to do some calculation. Okay. Okay. Okay, nampak tak ni? Okay, still the same number. This is the question on the synchronous motor. Tapi tak ada masuk drive pun. Ini just calculation yang you have done previously in the topic of synchronous motor. What is the rated speed and magnitude of rated IA of 405 kilowatt, 0.8 power factor lagging, 50 Hz, delta connected, lossless synchronous motor? Okay, in this case, you nak calculate the rated speed and IA. Okay, can you please go back to the formula for the synchronous motor? The power formula. How to get your IA? Ingat lagi tak? Synchronous motor tengok tu the power flow punya formula. Okay, please try to calculate this. I give you like 5 minutes macam tu. Buka balik nota. Kalau tak buat nanti terlupa, tak faham. Cuba buat. This is the recap Buka balik notes untuk synchronous motor. Cuba calculate. Ada tak? Macam mana nak buat? Apa formula for the power of the synchronous motor? Siapa ingat?
E equals to
3.
square root 3 VT Li cos theta.
Okay, satu lagi formula. Ada 2 kan? Satu yang kalau guna root 3. Satu lagi. 3 V phase.
I phase cos theta.
IA cos theta. 3 V phase IA cos theta. Okay, you can get your IA by using that formula. Cuba. What do you get? Pilih salah satu lah. Okay, at least you get the current dulu. Berapa? IA. And then cari the speed. The speed senang je kan? The speed 120 F over P. Ni number of poles tak bagi ke? Okay, number of pole dia 6 6. Okay, number of pole is 6. Ada nama. Okay, number of poles 6. You can calculate the speed. Then you use the power equation to calculate for the current. Cuba. Cuba tengok. Lagi siapa nak cuba? Please try. At least you akan belajar something. Refresh balik what you have learned previously. Sekejap Siapa lagi nak try? Baru 8 orang. Mana lagi ni? Kita nak discuss sekejap lagi. Okay, your attendance code ada dekat chat So 38 orang. Okay, dah. 9 orang je. Okay, thank you for those who participate. Okay, let's look at the question. Right. Okay. Okay. Okay, this question, nothing to do with the drive. It's a synchronous motor question that we have learned previously. Okay, tak ada kena-mengena pun dengan drive. So, how to calculate your speed, the motor speed Nm? Anybody? Which formula?
120.
120. Nm itu ke Ns rated to 120 times the frequency over number of pole. Okay, so the frequency given here is 50 Hertz and number of the pole is 6. So 50 Hertz over 6. So dia punya speed is 1000 RPM. So because the speed of the motor is equal to the speed of the synchronous speed, so satu je speed dia ada. Sebab dia ada straight line macam ni je untuk synchronous motor. Okay, this is the first value. So it is delta connected. Kalau delta connected, what does it mean? So VT line to line kan? Is equal to V phase. Okay, so V phase now is equal to 400 volt. So kalau dia Y connected, macam mana?
Divide root 3.
Line to line equal to square root V phase macam tu kan? So V phase equal to VT line to line over root 3. Okay, that's the only difference nanti kalau nak guna V phase, baru you kena make sure whether it is delta or Y connected. The difference is at V phase ni. Kalau dalam formula tu ada V phase, you must aware lah. Okay, now how to calculate the IA? So nak calculate IA, I remember I give you the power flow diagram for the synchronous motor. Kalau ada losses, you have to minus the losses. But this synchronous motor is a lossless motor. So you calculate IA, either you can use this formula, P in equal to 3V phase IA cos theta, where cos theta is your power factor. Okay, or you can use root 3 VT IL cos theta. Alright. Boleh ke sampai sini?
Boleh.
Boleh Doktor, boleh.
Okay, so rearranging, let's say I want to use this one lah, senang, with phase kan. Rearranging this formula, IA equal to, this is IA rated lah. P in rated equal to 3V phase rated cos theta. Okay, rated juga. So P in 5000 over 3 V phase 400 because it is delta connected times berapa ni? 0.8 kan? Okay, what do you get? Dapat berapa tadi? 5.21 ampere. So now, if let's say I want to find the angle for the current IA, berapa angle dia? Tak ada pun dalam soalan ni, tapi saya nak suruh cari angle. What's the angle for IA? Anybody?
36.87.
Macam mana dapat?
Inverse cos 0.8.
So cos 0.8 dapat 36.87. Is it like this? 36 saja ataupun ada minus? It's a lagging. So dia lagging. The power factor is lagging. So the angle for the current is equal to negative 36.87. Okay. So the current must have angle lah. Okay, because it is a three-phase motor. Boleh ke sampai sini? Boleh?
Boleh.
Okay. So, sampai situ dah. So, next, let's do one question. Okay, this is a question. Cuba tengok this question. Ambil gambar ke, cuba note down all the important information from this question. Okay, this is a question, one question on the synchronous motor. Dalam Brighton pun I dah bagi question. One example on the constant V over F control and one example on the variable frequency constant voltage control. Boleh watch the video nanti. Okay, a 6 megawatt 3-phase 11 kV Y connected 6 pole 50 Hz 0.9 power factor leading synchronous motor is used to drive a conveyor used to transport coal at a coal mine. So this coal, dia nak drive the coal, dia macam conveyor belt lah to drive the coal. Okay, and transport from one point to another point. So this motor has XS, which is the reactance of 9 ohm and negligible armature resistance. So RA equal to apa sekarang? RA equal to 0.
Zero.
The rated field current is 50 ampere. The machine is controlled at a constant V over F ratio up to base speed. Okay, all this information Rated. So maknanya kalau below base speed, it is controlled by V over F ratio. And a variable frequency with constant voltage above the base speed. So determine the torque and the field current for rated armature current 750 RPM and 0.8 power factor leading. Boleh faham? First, dia nak suruh calculate the torque. And the second one is the field current for rated armature current at the speed of 750 RPM, 0.8 power factor leading. So kalau tengok kat sini, the rated speed berapa? Ada rated speed dah? Belum kan? Belum calculate kan?
Cari.
Tak ada.
Okay, so let's start. First nak cari apa? Kita ada, this is power, 3 phase, volt, Y connected, 6 pole, 50 Hz, 0.9 leading, and XS, RA equal to 0, IF equal to 50. So first of all, macam mana pun, you have to find the rated speed because you ada this speed, the operational speed, and M new, but you tak tahu which formula you want to use because you still don't have the rated speed. So NM rated macam mana equal to which formula? Times F over the number of pole. Berapa dapat ni?
1000.
1000 RPM. Okay. So you ada 1000 RPM. You compare with the new speed 750 RPM is less than 1000 RPM. So which control strategy you want to use in order to control to reduce the speed?
V over F.
Okay, so NM apa dia? New equal to NM rated. Saya tulis satu-satu. So I hope you must do like this during the exam. Yang paper test tu ramai yang pakai calculate je, tak inform pun calculate kat mana. Okay, so you have to macam 2 points starting and end. You just calculate without informing the examiner kat mana you calculate. So macam next time in test 3 buat macam ni. Okay, you tulis satu-satu. So because it is below the rated speed, so you will have to calculate F new which is less than F rated. Betul tak? And you akan guna the constant V over F control. What about the terminal voltage? Kalau V over F ni. Terminal voltage ni macam mana cari?
VT equals to K
KV
flux
is
rated.
KV T rated. Okay. This is the voltage. These are all the information that you have learned before. Okay, now, so how to start? Kalau nak calculate torque for synchronous motor, nak guna formula mana? Which formula you want to use?
E equals to
Saya copy formula yang tadi. Where's the formula? Okay, this. Copy, kejap Okay, this formula you want to use in order to calculate the torque. So, the speed ada tak? Ada. V phase ada tak? Nanti you have to calculate for V phase new lah. Tak ada lagi. The speed je ada. Okay, now, what about XS? Do you want to use this XS 9 ohm or you have another XS?
UXS.
You akan ada X new, which equal to K over XS. So K ni macam mana calculate? How to calculate your K?
F new over F rated.
F new over F rated. So macam mana pun kita kena cari F new. Alright, how to find your F new? Formula mana nak guna? Senang je ni. F new dah ada. Number of pole tak berubah. So you can get your speed, right? Kat sini. Speed dah ada 750. So F new you calculate by using this formula. Okay, NM new equal to 120 F new over number of pole. Boleh? Ini lagi senang daripada induction motor. Okay, therefore, what's your NM new ni?
750.
750.
750. So, your F new equal to 750 times 6 over 120. What do you get?
37.5 Hz.
57.5.
37.5 Hertz. So, this is your new frequency. Once you get your new frequency, you can get your K. So, K equal to 37.5 over 50. And what do you get?
0.75.
0.75. Okay. So, once you get your K, now you can get your XS new and V phase new. How to get your XS new pula? You want to put in this formula because you want to calculate for the torque. Okay. So your NS new equal to 0.75 times berapa? 9.
9.
So dapat 6.75 ohm. The new reactance value. Okay. What about your V phase? Speed dah ada. You have to times by 2 pi over 60 later. XS new dah ada. So your V phase, how to calculate your new V phase?
VT
V phase equal to K. V phase new equal to K V phase rated. Sebab kita nak V phase kali ni. So we put in term of V phase times 400. Betul? Sebab dia delta connected. Berapa? 400 ke?
betul bukan Y connected.
Y connected, doktor.
Oh, sorry. Okay. So, bukan 400 ni, 11K. Okay, kalau Y connected macam mana? What is V phase?
Bagi square root 3.
11K bagi square root 3. Okay? Because it is Y connected. Okay? Berapa dapat?
6.35.
Berapa?
6.35 kilo volt.
Okay, 6.35 kilovolt. Boleh? Okay, sebab dia kali ni Y connected. Sebelum ni kita buat semua delta connected. So this is Y connected. Ni kena aware. So dapat 0.75 times 6.35K. So you akan dapat dalam
4.76.
14 volt macam tu. Boleh? Okay, now you ada V phase, dah ada omega M, XS. Apa lagi yang ada? Nak kena cari? Your EA. Macam mana nak cari EA? Ingat lagi tak ada formula? Oh, sorry, sekejap How to get your EA? Anybody?
KVL.
KVL around the loop. Okay. So tadi kita nak calculate EA new. Now we want to calculate EA new. We already have NM new. NM new equal to 750 RPM. Apa lagi yang kita ada? What about IA? Dia kata IA apa? At rated armature current. So at EA new ni, IA new equal to IA rated. Okay. What is the new power factor? This is the old power factor kan?
0.8.
So this is a new power factor. Power factor new 0.8 leading. Okay. So which formula you want to calculate your EA? Is KVL around the loop. So EA new equal to V phase new minus Allah Akbar. Hilang ke? Okay. IA new times RA plus JXS ini yang mana? Semua new ya?
This
Yeah.
is new.
So this is based on new frequency. F new which is calculation ni semua waktu F new 37.5. So kita dah transform all the values into the new value. So how to get, you nak calculate for EA new in order to put in this formula. You ada V phase, RA is equal to 0, XS new pun dah ada. What about your IA? How to calculate your IA? Tadi kita dah buat dekat dalam menti. How to calculate your IA?
Guna power.
So IA rated equal to P in rated over 3V phase cos, ni rated juga, semua rated, cos theta rated. Okay, berapa P in? What's the value of P in?
6 megawatt.
Why 6 megawatt? Actually sebenarnya berapa P, kenapa kalau kat sini kita P in ke P out? IA ni.
EE.
Kalau kita tengok this is P in kan? This is P out. Dalam power flow tu kalau dia ada losses lah kat sini. Losses due to resistance and macam-macam. Okay. So in this case P out equal to P in ya. In this case P out equal to P in. Sebab kenapa? Sebab dia lossless. Okay. So kalau nanti kalau ada losses, kata dia kejap ni kan. Yang given 6 megawatt ni apa? P in ke P out?
P out.
P out. So if you ada losses nanti, you kena P in, you kena sama juga P out tambah all the losses ya. P losses. In this case, because it is lossless, P in equal to P out, so you'll be using this formula. So 6 6 mega over 3. V phase berapa? Kita nak ambil 11 ke nak ambil berapa V phase?
11 dari √3.
Okey, tadi kita dah kira 11,000 divide by √3 is equal to 6.35k kan?
Betul.
Betul eh? And what about the cos theta rated? You want to take 0.9 or 0.8?
0.9.
0.9 because this is at rated value. Boleh faham ke? Okay, put this in your calculator. What do you get?
349.96 ampere.
349.96
96.
ampere. Semua dapat macam ni ke? Yang lain?
Sama.
Sama. Okay, now what about the angle? If it's a three-phase, your current must have angle. So what is the angle for IA?
25.84.
Minus cosine 0.8. Berapa tadi?
25.84.
25.84. Okay. Okay, sekarang saya nak tanya. For the angle, why you choose 0.9? Cos 0.9 instead of 0.8.
Rated.
Rated
Tapi
current.
sekarang kita nak cari IA new. IA new is equal to IA rated. Is in term of the value. We want to put here is IA new. Dia kata IA new is at rated current armature. But the angle now, should we take 0.9 or 0.8?
0.8.
0.9.
0.9 ke 0.8? This is IA new.
9.
0.9, yes. IA rated, we take only the value, okay, the magnitude. But the angle, because this is a new IA, it must based on the 0.8 power factor leading ni. This is for rated. This angle for rated. Yes, we take the magnitude for the new current, but the angle must base on the angle of the speed at 750. Ini at 750 kan? At the new speed of 750, the angle is cosine 0.8. Boleh faham tak? The only thing that we take from the rated is the magnitude of the current. But if we have the new angle at 750 at 0.8 power factor leading, so we must take the value or the angle at 0.8. Okay, what do you get?
36.87.
Betul.
36.87. So is this positive angle or negative angle?
Positif.
Positive, why?
Leading.
Because it's leading, yeah. So put in all the values. So V phase tadi dapat 4763.14. What's the angle for the phase voltage?
Kosong.
0.
0. It's always 0, eh. So IA equal to 349.91 angle 36.87 and J, what's the value of XS tadi? 6.75. Okay. Can you please calculate for new EA? For this new EA? What do you get? Berapa dapat? Siapa dah dapat, tolong inform the answer, eh. Anybody?
Saya mana tengah kira.
Okay. Saya bagi peluang. Nanti cakap answer.
Six one at 0.28.
Berapa?
6180.
6180. Yang lain ada tak? Lain sikit daripada jawapan saya. Sekejap tunggu dulu. Yang lain dapat berapa? Please please calculate sendiri, then you will learn. Dalam kelas ni tolong buat, nanti tak payahlah buat dah kat rumah.
6462.
Ha? 6 tu dah betul. 6.
6462.
Yes, saya dapat macam ni. 6462.7.
94.
7. Ambil 7, tak apalah. 64.62. Lebih kurang macam ni What's the angle?
Negatif 17.
Okay. Negatif 17 degree. Okay. This is your EA. So, you ada EA. EA, this one take the magnitude. What about delta? Del ni. Which angle?
Yang baru.
6.87.
Okay, for synchronous motor, this is the value of del. Kalau synchronous motor, the value of del ni must always negative for synchronous motor. Kalau synchronous generator dia akan positif. But in order to take for calculation, you ambil je del ni 17 degree without the sign This is the angle del 17. So V phase dah ada, omega dah ada, XS, EA, sin del pun dah ada. Let's calculate for the top. Okay, semua letakkan, put all the values in the top. Calculate for the top. Okay, we are using this value. This equation. TE equal to 3 V phase. Berapa V phase tadi? 6350.85. EA equal to 6462.67. Sin 17 over, tulis dulu, top at nm rpm. Okay, omega m berapa? 750 times 2 pi over 60 times xs 6.75. Okay, this is the calculation for new torque at the speed of 750. Okay, please calculate. What do you get? Saya pun
Madam,
ya.
kenapa kita guna V-Phase 6350 Kenapa
Yes. Kejap, saya tak dengar, saya nak kuatkan sikit saya pun. Oh, okey, apa soalan?
Kenapa kita guna V-Phase value 6350? Kenapa tak guna yang 4763?
Alamak, salah. 47. Oh, ya, betul. Sorry. Betul. V-phase dia. Tadi V-rated kan? Okey, 4763. Okey, ini 4763.14. Okey, this is V-phase new kan? Guna V-phase new. Thank you. Bagus alert tu. Yang lain semua okey tak?
679.
679. Okey, ada yang dapat 679 Nm. Saya tak calculate ni. Jadi saya waiting for your answer. Betul tak semua dapat 679? Yang lain? Betul tak? Please check.
Salah.
Salah. Okey. Berapa? Kalkulate lain. Ini dah salah. Saya pun tak calculate lagi ni. Tolong kita calculate sama-sama. You all ada ramai ni. Kita calculate and compare the answer. Berapa? Siapa yang dapat? Please give your answer. Mana the girls mana? Girls ada calculate tak? What do you get? Senyap saja the girls ni. Malu? Cepat. Berapa ni? Berapa minit lagi tinggal ni? Kata nak habis kelawar.
50k.
5929 Newton meter.
50. Ada point-point tak?
929.
59.29.
Point 37 Newton meter.
Okey. Semua dapat macam ni ke?
Dapat.
Okey.
Dapat.
So this is your answer. Lebih kurang 50.93 kilo Newton meter. Okay, that's the answer. So, today, dah ada berapa minit nak tinggal ni, kita tak sempat buat field current. Boleh tak I ask you to go back home and try to do for the field current? Boleh ke? Okay, for the synchronous motor, kita dah buat hari ni for torque calculation at new speed. And this new speed is below the rated speed. Okay, below rated speed. Kita dah guna constant V over F control. And from this V over F control, we are finding the new frequency. And when we have the new frequency, we have the new motor speed, new XS, and new V phase. Okay, so when we have all that, we put into this equation to calculate for the torque, and we also calculate for EA new based on the new speed. Okay, at rated current. So kalau dikata at rated current, yes, you have the value of current, the magnitude of the current IA equal to IA rated, but the angle, you must look at the angle of operation at 750 RPM. Dia punya angle is 0.8 power factor leading. Okay, you cannot take at 0.9 because this is at rated. Yeah, boleh ke? So that's the end of our class today. We already did one question on the torque calculation, and on Thursday we continue because we have another question and we also have to find the field current. Alright, any question before we stop? Ada soalan ke? Ada soalan?
Ada.
Tak ada? So kalau tak ada soalan, that's all for today. Download attendance, berapa orang datang ni? 37 orang je. Okay, so hope to see you on Thursday and have a great day today. Bye. Assalamualaikum.
Thank you, Doctor.
Thank you.
Ya,
Thank you.